Picture this exact moment. The sun is out. It is warm, steady, completely ordinary. You are standing in your backyard, coffee in hand, squinting up at the same star that has been there every single morning of your life. Nothing looks wrong. Nothing sounds wrong. The birds are still going. The neighbor's dog is still barking. But somewhere up there, 93 million miles away, something just happened that has no precedent in the history of this solar system. The sun stopped spinning, not exploding, not dimming, not dying, just quietly, impossibly, stopped rotating on its axis. And you have absolutely no idea that everything just changed. Here's the first thing you need to understand. The sun does not spin the way a basketball spins. It is not a solid object. It is an enormous ball of plasma, and different parts of it rotate at completely different speeds. The equator of the sun completes one full rotation in roughly 25 days. The poles take closer to 35 days. That difference is not a quirk. That difference is everything. Scientists call it differential rotation, and it is the engine behind one of the most important structures in the entire solar system, the sun's magnetic field. When plasma moving at different speeds drags magnetic field lines along with it, those lines twist, stretch, and reconnect. That constant churning, that perpetual magnetic violence, is what generates the heliosphere. And the heliosphere is the reason you are alive. Before this video is over, you will understand exactly why. We are going to walk through what breaks first, how the damage accelerates, and then we are going to arrive at a conclusion that almost nobody expects. The greatest threat from a sun that stops spinning is not heat. It is not gravity. It is silence. So where does it start? In the first hours, you feel nothing. You see nothing. But deep in the machinery of space weather, something is already going wrong. The structured solar wind, the constant stream of charged particles the sun breathes outward in all directions, begins losing its shape. Solar wind is not random. It flows along the architecture of the sun's magnetic field, and that architecture depends entirely on the rotation that just stopped. Without the differential spin to twist and reconnect magnetic field lines, the process called magnetic reconnection begins to stall. Coronal mass ejections, those massive eruptions of magnetized plasma that occasionally threaten our satellites and power grids, start to quiet down. That might sound like good news. It is not. Those eruptions were symptoms of a living magnetic system. Their absence means the system is dying. By the end of the first week, the solar wind is still flowing. There is enormous momentum in a structure that size, and it does not vanish overnight. But its pressure and coherence are already degrading. And here is where the scale of the problem becomes difficult to fully hold in your head. The heliosphere extends more than 120 astronomical units from the sun. 1 astronomical unit is the distance from the Earth to the sun. In 2012, NASA's Voyager 1 spacecraft crossed the outer boundary of the heliosphere, the heliopause, at roughly 121 astronomical units. That means the sun's magnetic bubble stretches so far that light traveling at the speed of light still takes more than 16 hours to cross it. This is not a local phenomenon. This is a structure larger than 1,000 suns lined up end to end, and it exists entirely because the sun is spinning right now. Think of it as a 3-layer system of protection. The first layer is Earth's atmosphere, which absorbs ultraviolet radiation and most of what the sun throws at us directly. The second layer is Earth's own magnetic field, the magnetosphere, generated by the churning liquid iron in our planet's core. But the third layer, the outermost, largest, and least discussed, is the heliosphere. It acts as a bubble that deflects and slows galactic cosmic rays, the high-energy particles produced by supernovae and other violent events across the Milky Way. Those particles travel at a significant fraction of the speed of light, and without the heliosphere, far more of them reach the inner solar system. Far more of them reach us. In the weeks following the sun's rotation stopping, the first sign that most people would actually notice is the disappearance of the northern and southern lights. Auroras happen when charged particles from the solar wind get funneled into Earth's polar regions by the magnetosphere and collide with atmospheric gases. Fewer structured solar wind particles means fewer auroras. Then none at all. It seems cosmetic. It seems like losing a beautiful, natural display. But it is actually the first visible signal that the sun's magnetic output has fundamentally changed. It is the canary. And the canary just went quiet. Now here is the part that surprises people. The sun, throughout all of this, is still shining. It is still fusing hydrogen into helium in its core at the exact same rate it was yesterday. The light reaching your face is identical. Your solar panels are still working. Your vitamin D production is unchanged. Nuclear fusion in the sun's core does not depend on surface rotation. The sun could keep producing light and heat for billions of additional years without ever spinning again. So you might reasonably ask, if the sun is still shining, where exactly is the emergency? The emergency is in what you cannot see. Galactic cosmic rays are flooding the solar system in increasing numbers. And over the following months, instruments measuring radiation levels at high altitudes start registering readings outside normal ranges. It is subtle at first. High-altitude aircraft crews accumulate slightly more radiation per flight hour. Astronauts in low Earth orbit face elevated risk. Satellites begin showing increased rates of bit flip errors in their electronics, caused by high-energy particles passing through their circuits. At ground level, the atmosphere still provides significant shielding, but the trend is moving in one direction, and it is not moving slowly. Estimates based on what scientists know about periods of low solar magnetic activity suggest that a complete and permanent collapse of the heliosphere could increase galactic cosmic ray flux at Earth's orbit by somewhere between 2 and 5 times current levels. That is not a precise number. It is a modeled range with real uncertainty, but even the low end of that range represents a meaningful change in the radiation environment of an entire planet. And this is only months in. The heliosphere does not vanish instantly. The solar wind already out in space continues propagating outward for decades. But the source has stopped. The reservoir is draining, and waiting on the other side of that boundary is everything the galaxy has been throwing at the solar system for billions of years, held at bay entirely by a star that was quietly spinning. By the time a full year has passed, the change in cosmic ray flux is no longer just an instrument reading. It is a biological fact. Scientists estimate that the radiation dose at Earth's surface could eventually climb to something comparable to living permanently at extreme altitude, except without the option of coming back down. And unlike altitude, you cannot engineer your way around galactic cosmic rays with sunscreen or a hat. These are particles energetic enough to pass through the hull of a building. They interact with DNA. They do not always cause immediate damage, but they accumulate. Every organism on the surface of this planet is now absorbing slightly more of something that was never supposed to reach them in these quantities. The organisms that handle it best are the ones that have always been built for punishment. Deinococcus radiodurans, a bacterium so resistant to radiation that scientists have nicknamed it Conan the bacterium, can survive doses thousands of times higher than what would kill a human. In this new world, life like that does not just survive, it thrives. The selective pressure has shifted. Complexity becomes a liability. Exposed surface life faces rising rates of mutation, rising rates of cellular damage, rising rates of reproductive failure in organisms that were never designed to absorb this much. Plants on the surface begin accumulating DNA errors faster than repair mechanisms can correct them. The food chains built on those plants begin to feel the pressure upward. Meanwhile, something else is happening that most people would never think to look for. Manchas solaris, the dark regions on the sun's surface caused by magnetic field concentrations emerging from differential rotation, have completely disappeared. The sun looks cleaner, smoother, more uniform. And if you did not know what you were looking at, you might think that was a good sign. A calmer sun, a quieter sun. In reality, the absence of sunspots is not the sun becoming safer. It is the sun's magnetic system going silent. It is the EKG flatlining. Every sunspot that ever formed was evidence of the same churning, twisting differential rotation that was maintaining the heliosphere. No sunspots means no active magnetic dynamo. It means the clock on the heliosphere's remaining life is now running in one direction only. In the decades that follow, the residual heliosphere continues to weaken as the outward-flowing solar wind thins progressively. The cosmic ray environment at Earth's orbit keeps rising. The ozone layer, which relies in part on the complex chemistry driven by the solar wind's interaction with the upper atmosphere, begins to behave erratically. Ultraviolet radiation at the surface starts climbing. The combination of elevated galactic cosmic rays from space and elevated ultraviolet from above creates a surface environment that is measurably more hostile to complex life than anything experienced in the last several hundred million years. Not all at once, not in a single catastrophic moment, slowly, relentlessly, silently. Over centuries, the biodiversity of surface ecosystems faces a pressure unlike anything in the geological record. Past mass extinctions came from impacts, from volcanic winters, from rapid climate shifts. This one comes from the sky being slightly wrong, in a way that never corrects itself. Life does not disappear overnight. Life is extraordinarily stubborn. But complex multicellular organisms, the ones with elaborate DNA repair requirements, the ones that need stable ecosystems to feed and reproduce, begin a long retreat. Ocean life shielded by water fares better. Deep subsurface life, untouched by any of it, carries on entirely undisturbed, the way it has for billions of years. But the surface, the thin, bright layer where almost everything we call civilization exists, becomes increasingly inhospitable. Now here's the thing that almost nobody considers, and this is the part worth sitting with for a moment. The sun has already shown us, in a much milder way, what reduced magnetic activity looks like. Between 1645 and 1715, the sun went through a period of dramatically reduced sunspot activity called the Maunder minimum. For roughly 70 years, the magnetic pulse of the sun was unusually quiet. Researchers have found evidence in ice core data that galactic cosmic ray flux increased measurably during that period. Temperatures dropped slightly in parts of the northern hemisphere. It contributed to what historians call the Little Ice Age. The sun was still spinning during the Maunder minimum. Its magnetic system was weakened, not destroyed, and even that modest reduction left a fingerprint in ice 2 miles thick. What we are describing here is not a Maunder minimum. It is a Maunder minimum in the same way that a candle is like a supernova. So now we can answer the original question directly, with the precision it deserves. If the sun suddenly stopped spinning, the Earth would still exist. The sun would still shine. The oceans would not boil. Gravity would not change. Your coffee would still be warm. But the invisible architecture that makes complex life viable on this planet, the layered magnetic system that took billions of years to build, would begin an irreversible collapse. Not immediately, not even noticeably at first, but within decades, the radiation environment of the solar system would be transformed. Within centuries, the surface of this planet would be a fundamentally different place. Life would persist because life always finds a way. But civilization, and probably most of the complexity that makes the biosphere what it is today, would face a slow and silent extinction, unlike anything in our history. The planet survives, the world we know does not. The scientific uncertainties here are real and worth naming clearly. We have never observed a star stop spinning. The timescales involved in heliosphere decay are modeled, not measured. The exact increase in cosmic ray flux is an estimate with a meaningful range. The biological consequences at specific doses are extrapolated from existing data, not observed in this scenario. What the science is confident about is the direction. Remove the rotation, you remove the magnetic dynamo. Remove the magnetic dynamo, you lose the heliosphere. Lose the heliosphere, and the galaxy gets in. The details are uncertain, the trajectory is not. The next time you step outside on a clear day and feel the warmth of the sun on your face, consider this. That warmth is not the sun's most important gift to you. The most important thing the sun is doing right now is spinning, quietly, continuously, at speeds your naked eye will never detect. It has been doing it for 4.5 billion years. And somewhere in that rotation, in that invisible differential churn of plasma and magnetic field lines, is a bubble of protection 120 astronomical units wide that stands between you and everything the rest of the galaxy is capable of throwing at us. You have never seen it. You will never feel it. But right now, it is out there, holding the line.